same data in which we are given diameter of tennis balls as 6.7 centimeters with a standard deviation value of zero point 0.3, and we are asked to draw sample size of 16 instead of 1. So we have discussed in the previous lecture video of the same series that R variable changes from x to x bar. Now we need to understand the basic characteristics of the sampling distribution of x bar, that what will be the connection between x and x bar. So when we consider the sketch of x, let's assume that this is the sketch of x where the variability of this random variable x is represented with the random variable when the with the help of standard deviation, and this is mu, the position at which the mean is located. Now what I would do, I would change the color to draw another curve, and the curve with another color in fact, and this would be for x bar. And then you can see that the location of the center of the two curves or both the curves are at the same position. So we can say that mu is equal to mu of x bar. But as far as variability, you can look at the variability of curve x, sigma of x, we can say that greater than that of sigma of x bar. So we need to consider this aspect that whenever sample size increases to certain value n, and when we sketch the curve of x bar, consequently the curve of x bar is steeper than that of curve of x, and it refers or represents that there is a lower degree of dispersion or less degree of dispersion with respect to the mean value we observe in x bar as compared to variable x. Now you can see over here I have drawn both the curves as a bell-shaped curve. Why is this so? Because whenever we draw a sample from a population, so basic characteristics of the sampling distribution of X bar depend upon the shape of the population or parent population from which the sample is drawn. And in the question, it is already provided as an assumption that the diameter of the tennis balls or individual tennis balls follow normal distribution. So when we draw 16 tennis balls from the same population, so sample mean obtained on the basis of 16 different diameters will give us the shape of the distribution of x bar same as normal. So we can say that the sampling distribution of random variable x bar also follow normal distribution because the population or parent population from which it is drawn also follow normal. That's why the sampling distribution of x bar will also follow normal distribution. Now there are two things we need to consider, that what will happen to the population mean and what will happen to the standard error of the mean. Over here I am using the word standard error. So when we write down the formula of this with random variable x bar, so we have derived in the previous lecture video this result and proved it that mu of x bar equals to mu. So when we draw the sample size of 16 or any sample size n, nothing will happen to the population mean. Mean of the sample means will be equal to population mean. Considering sigma of x bar, so now the variability of the sampling distribution of x bar will now be represented with sigma of x bar, that is equal to sigma divided by root n. This sigma of x bar basically we call the standard error of the mean. Standard error of random variable x bar because it captures the variability of x bar because it is sensitive to the sample size. So we can say that standard error of x bar is inversely proportional to the square root of the sample size. The greater the sample size will reflect the smaller standard error values because greater sample size will contain greater representation of the population in the data. Therefore, we expect it to be less variable because mean we get on the basis of sample size 10, then 20, then 100. So we find out greatest representation in case of sample size 100. Now when we compare the two mean values in case of sample size 10 and in case of sample size 100, if we have drawn all possible samples in both the cases, then this equality of population mean and mean of the sample mean will always exist. But what will happen to the standard error? Standard error of the sample size of 100 observations will always be less than that of the sample size of or in case of the sample size of 10 observations. So this is what the generalization we need to make. So two things we have discussed here in this video. One is the behavior of the sampling distribution. If the sample is drawn from normal population, it will also follow normal distribution. So the shape of both the distribution, whether it is x or x bar, since x follows normal, x bar will also follow normal, and consequently both will have a bell-shaped curve. As far as variability mean is concerned, mean of the sample mean will be equal to population mean. As far as variability of x bar is concerned, so what will be the variability of x bar? That depends upon the sample size we are dealing with. And this we call standard error.